All right, everybody. Today our focus is going to be associated ratios and the value of ratios. Now, a simpler way of thinking of this is here is the relationship between two things, and here's how I use that relationship to solve math problems. And number one gives us a really good example of how that would work. So we're asked the question, which of the following correctly models that the number of red gumballs is 5/3 the number of white gumballs? Now you notice that's not a ratio. What is that? That is correct. That, my friends, is a fraction. However, fractions and ratios are very, very, very similar. Fraction is a piece of a whole, but a ratio is a relationship between two numbers. However, I can state the ratio as a fraction when doing multiplicative comparisons. So when I'm multiplying things or I'm comparing things, I can state it and write it as a fraction. So what we're going to notice is we've got 5 up top and 3 down below, and we've got red gumballs is 5/3 the number of white gumballs. So that would mean that the 5 up top represents the red gumballs, and the 3 down low represents the white gumballs. So as a ratio, I could write that 5:3, red to white, or I could say that it is 5/3 red gumballs. So hopefully that helps out just a little bit. So here we see in example 2, it talks about the duration of 2 films are modeled below. And this looks pretty familiar. We use this in ratios. It's a model that really helps. It is called a tape diagram. Very good. It is a tape diagram. And tape diagrams help us figure things out. And so they help us figure out ratios. And I can see that film A was 5 parts to film B's 7 parts. So I would say that ratio as 5:7. But then it can use it in the multiplicative sense by using it as a fraction, and we're going to see that right here, where we have that it is a blank blank of the length of film, and they don't use the word 2, they use of, so it's therefore a fraction. And so what we do is we're filling in A on top, 5, 7 in the bottom, so we could say that the length of film A is 5/7 the length of film B. And that makes sense because if you were to say that the whole amount, sorry about that, is for 7 parts and film A is only 5 of that whole, then you would say that it is 5/7 or less than the whole part of 7. And then we could switch that around and say, what about the length of film B compared to the length of film A? So if the length of film A is the whole, well, film B is longer. And so this would have to be more than one whole movie of film A plus some more, right? And so that would be 1 2/7, or we'll just write the numbers that it gave us, which of course is 7/5. This was a really fun problem in my class because we got to have a nice long debate and lots of discussion over problem-solving skills and strategies. But I think the biggest key that we all came up with was understanding the language used in this sentence and in this sentence. Knowing when to add, subtract, multiply, or divide is key in mathematical problem solving. So it said that Sammy brought 8 more shrimp than Caden brought, and since we see that more than, we know we're subtracting, and so that means that Sammy's amount minus Caden's amount has to equal 8. Continuing on, it says when they combined their shrimp, they had 32 shrimp altogether. Well, again, we are combining, but we know they're unequal groups because we saw that in this problem that this number minus this number equals 8, which means they can't be equal. And therefore, we're just combining 2 different groups, which is addition. So that would mean that Sammy plus Caden has to equal 32. So let's say we use this tape diagram. We have a ratio of 9:1, and that would equal our Sammy versus Caden because 9 is 8 more than 1. I can start there. However, since I know my total has to be 32, then I'm going to have to keep yeah, 32, I'm going to have to keep gaining both sides. So if I put 1 here, I also have to put 1 here. If I put 1 here, I also put 1 here. This is just one strategy to solve it, where using tape diagrams really ends up helping, because what you end up finding out is as I continue to do this and get to 32 as my total, I'm going to end up with a certain amount on top and a certain amount on bottom that has a difference of 8, and it has a total of 32. And here you can see, as I finished up, that it ends up being 20 for Sammy and 12 for Caden, which is a total of 32. So 20 on top, 12, and that leaves me a gap here of 8. So mathematically, that means I did Sammy minus Caden equals 8. So Sammy had 20, Caden had 12. That gave me 8. And then that means that I have to use those same numbers, S and K, so the 20 and the 12, and they should add together and equal 32. So 20 plus 12 equals 32, and that is correct. And back to the story, you can see that Sammy had 20, Caden had 12. And if I want to write that in a ratio, which is what I'm doing down here on letter B, then the ratio would be 20 to 12. I could also write it 20 to 12. And as a fraction, I would express it 20 to 12, or 20/12ths. And the cool thing about ratios and fractions is I can use all the elements of the relationships. Not only do I have Sammy and Caden's types, but or amounts, I also have the total. So if I wanted to do Sammy to the total as a ratio, I would just use Sammy's, which was 20, to the total 32. And as a fraction, that would be 20 30-seconds. And for my math whizzes out there, I can even simplify that fraction and the ratio by finding equivalent fractions or ratios. If I divide each one by 4, the numerator and the denominator, and 20 divided by 4 is 5, 32 divided by 4 is 8. So I could say that 20 30-seconds is the same as 5/8. He brought 5/8 of the shrimp, which is clearly more than half, so he's doing okay. And I think it's pretty helpful of him. Okay, so this question says a food company that produces peanut butter decides to try out a new version of its peanut butter that is extra crunchy using twice the number of peanut chunks as normal. So right away I know that, I could highlight this twice right here. That'll probably come in handy. And then I've got extra crunchy and I've got normal. So I can see that I'm going to have some relationships here. For example, the extra crunchy has a 2-to-1 peanut ratio to the amount of peanuts in the normal kind. I don't know if I'm going to need that or not, but let's keep going. The company hosts a sampling of its new product at grocery stores and finds that 5 out of every 9 customers prefer the new extra crunchy, I kept saying country earlier in class too, crunchy version. So if I were to write that as a ratio, I'd write 5 to 9, and the 5 represents the new likers, and the 9 represents the total number of people surveyed. So again, what it said was 5 out of every 9 customers. So if I had 1, 2, 3, 4, 5, 6, 7, 8, 9 customers, that means that these 5 like the new. Well, you can see that leaves me these 4 who like the old. And that is a total of 9. Does everyone understand how that works? Good. So if you'd like to pause this video at any time to skip ahead, feel free, but I'm going to go through these answers. The ratio of number preferring new extra crunchy to total number surveyed was, again, what we just write, new 5 to 9. The ratio preferring regular, that would mean that I had 4 that were right here, right? 4 that of the 9 liked the old one, and then of course the total stays the same, that's 9. And so the ratio of the number preferring regular to new would be 4 to 5, and the ratio preferring new to regular would be 5 to 4. And we can see pretty simply that all we had to do was swap the 4 and the 5 and the 5 to 4, as well as the description there. So looking at B, as we move on down, using the value of each ratio to make multiplicative comparisons. And this is what we were talking about earlier by using fractions. So the number for new crunchy is 5/9 of the total. Those preferring regular was 4/9. And regular to new country was 4/5. And then new crunchy to regular crunchy was 5/4. I apologize if I said country again. For some reason I can't say crunchy. I'm saying country. Letter C, if the company is planning to produce 90,000 containers of crunchy peanut butter, how many of these containers should be in the new extra crunchy variety, and how many of these containers should be the regular crunchy peanut butter? What would be helpful in solving this problem? Does one of our comparison statements help us from above? So I have two preferred methods. One would be the tape diagram, in which case I would use either the 4:5 or the 5:4 ratio of regular to new. So I'm going to do 4:5, and that's 4 of the regular to the 5 new. And I just make my tape diagram. And then it says that I made 90,000, so that means that all my pieces combined is 90,000, which I would be 90,000 divided by my equal parts, which is 1, 2, 3, 4, 5, 6, 7, 8, 9 equal parts. And again, knowing my rules with tens, I can see that what I really have here is 9 divided by 9. And 9 divided by 9, everyone knows, is 1. But then I can see that I had I had ignored 1, 2, 3, 4 zeros. So when I'm dividing, I take zeros away. But since I'm not taking any zeros away, there's no zeros over here, I ignored these 4 zeros. Then I'm just going to leave those 4 zeros alone. So I'm going to put my 1, and then I put my 1, 0, 2, 3, 4 zeros. So each box represents 10,000. And if I get real small here, I can write 10,000 in here. And I'd have to do that for each and every box. Because if one is worth 10,000, they're all worth 10,000. Having that said, that lets me know that this one is 40,000. And this one would be 50,000. Moving on to letter D, if the company decides to produce 2,000 containers of regular crunchy peanut butter, how many containers of new extra crunchy peanut butter would it produce? Which gives me this diagram, regular and new. There's 2,000 of regular, and then there's however many of new, I don't know, but the 2,000 is broken into 4 equal pieces. So 2,000 divided by 4 is going to be 500. And if these are worth 500, all of them are worth 500. And so that would, to answer the question, how many new, that would just be 5 times 500, which is going to be 2,500 new. So another method I like is the table method, where I transfer the ratio into a table, and then I often add, it's just a double T table, and I add the total over here. So this is regular is 4, 2, the new is 5, and the total is 9. And the question says if they produce 10,000 new extra crunchy peanut butters, so I've put that in the new category up underneath here to start a new section, how many containers of regular would they be? So since we're looking to find the same rate of change, I have to figure out how do I get from 5 to 10,000. Well, again, I can use my super special trick with zeros, and I can try to remember how do I get from 5 to 10. Well, we know that's times 2. Very good. So if I just kind of pull this out, it's times 2. But then, how many zeros did I ignore? 3. So I put those 3 back on. I'm multiplying it by 2,000. Which means I also have to multiply the 9 times 2,000. And to stay equivalent, I have to multiply the 4 times 2,000. But this would also work up here when I would just mark this part on the back, the new, and the total of it would be 10,000 divided by 5 would be 2,000.